Hello, Math 2 Plus. It's Miss Scott back for another day of math. Before we jump into today's lesson, let's go ahead and review real quick a little problem from last time. Go ahead and hit pause to try out the problem and hit play when you're ready to check your answer. So for this problem, we're asked to name the solid formed by stacking similar shapes so that each layer is a slightly smaller shape than the previous layer. So I have a hexagon on my base here, but I'm going to put a smaller hexagon on top of that and a smaller hexagon on top of that and keep going and keep going and keep going, which does end up giving me a pyramid. But remember, with our pyramids and our prisms, we like to name them by their bases. So I'm going to call mine a hexagonal pyramid because it does have a hexagon for a base. Great work. Let's go ahead and move on to today's lesson now that we're all warmed up. So today we're on lesson 10-2. We're still talking about volume, but today we're going to focus in a little bit more on finding the volumes of prisms and cylinders specifically and ways that we can do that. To kind of get in your head of how we're going to do this, I'm going to go ahead and leave this with you right here. Go ahead and take a moment to read through and answer the question. Hit pause as you think about it and then hit play when you're ready to check your work. So the idea here is that we're going to compare the area of these two figures shown. And you'll notice that each rectangle has a height of h and a base length equal to L. And so I've got 1, 2, 3, 4, 5, 6 of these rectangles. But this guy also has 1, 2, 3, 4, 5, 6 of the exact same rectangles. So they actually do have the same area. Which seems a little weird, but if you think about it, it kind of makes sense because whether you're standing up straight or whether you're leaning over a little bit, you're going to have the same area. And in fact, you may even notice that if you were going all the way from bottom to top, these guys even have the same height as well as the same base. This idea that even if they have the same base and you've got the same height gives you the same area is called Cavaliere's principle. And the whole idea is that if two three-dimensional figures have the same height and the same cross-sectional area at every level, then they're going to have the same volume, whether it's a right cylinder or an oblique cylinder, or a right prism or an oblique prism. Remember yesterday we talked about how oblique meant that it was leaning a little bit? They're still going to have the same volume. Whether it's standing up straight or whether it's leaning over a little bit, the volume is going to be the same. In the case of these cylinders, the radius is going to be the same. The height, top to bottom, is going to be the same. The volume is going to be the same as well. So with this concept in mind, this means that a really easy way to find the volume of a prism is to think of it as the area of the base times the height. All you need to know is the area of the base and the height of your prism, and you can find the volume. That does mean it's going to be super critical to find that big B, that area of your base. And that means it's going to be very critical to know which side is your base. Please remember that with bases, there's always two of them. They are congruent to each other and they are parallel to each other as well. And hopefully that'll help you find your base. Don't be fooled. The base is not always necessarily on the bottom. So watch out for that. But if you can find the area of whatever shape is your base, whether it's a rectangle or a triangle or whatever it is you're dealing with, then you shouldn't have any trouble finding the volume. You just need the area of that base, multiply it by the height, and it works. Because remember, area is measured in units squared, and your height length here would just be measured in the units. If you multiply them together, you get units cubed, and that is what volume is measured in. So with this idea in mind, I'm going to throw example 1 your way. Go ahead and hit pause, and then hit play when you're ready to check your work. So for this particular problem, we are once again asked to find the volume of the prism. I know you're not surprised by that since that's what we were just talking about. Please remember that the volume of your prism is the area of your base. Remember, big B is the area of the base times the height. In this case, it looks like my base is just a plain Jane everyday rectangle. Well, how do you find the area of a rectangle? Length times width, right? So fine, I can just do my 24 centimeters times 20 centimeters. That tells me that the area of my base is 480 centimeters squared. So if this is my base, then this little lateral edge here must be my height. So it looks like my height is 10 centimeters. So if I plug in the area of my base, if I plug in my height, multiply them together, and I get 4,800 cubic centimeters for the total volume of the prism. How'd you do? Good, I hope. Why don't we try another one? I think you're there, but I gotta mess with you just a little bit. So here's example 2. Go ahead and hit pause and then hit play when you're ready to check your work. So for this particular problem, we are again finding the volume of the prism. So that means we need to decide what our base is because it's going to be the area of the base times the height. Now, remember what I told you about last time earlier on, how the base does not have to be the bottom. It can't be this rectangle because there's not a matching parallel rectangle up above it. But you know what? This triangle sure does have a congruent parallel little triangle on the other side. So I think that our base is a triangle. Well, how do you find the area of a triangle? 1/2 base times height. The base of this triangle is 20, but I don't know its height. I do know its hypotenuse. You know what that means. It's Pythagorean theorem time. So my little missing guy squared plus 20 squared should equal my hypotenuse squared, which is 29. He's right over there. You may want to grab a calculator at this point just to make sure your numbers are okay, because 20 squared will give me 400, 29 squared will give me 841. If I subtract the 2, I get 441. Please don't forget that you undo a square with a square root. So it turns out my missing little length here is 21. So now I can find the area of my triangle. 1/2 20 times 21 should give me the area of my triangle, or the area of my base, which is 210 meters squared in this particular case. So if this is the base, what's the height going to be? Well, if this is the bottom, then this must be the height, my lateral edge over here, 40 meters. And now that I have my big B and my H, I can plug them on in and find out that the total volume of this prism is 8,400 meters cubed. So this one was sneaky. He had a few extra tricks to him, so watch out for that. Make sure you know what your base is. If you know the area of your base, you can totally find the volume of this prism. Just make sure you can identify that base. It's all about the base. No trouble. Moving on to volume of cylinders, exact same idea. You're still going to be able to find the volume of a cylinder as the product of the area of the base times the height of your cylinder, just like prisms. But what makes cylinders different from prisms? Well, in this case, the area of the base is a circle. So usually, instead of writing it as volume equals area of the base times the height, I know the area of a circle. The area of a circle, which we were playing with before we went on spring break, is pi r squared. So I love cylinders. They're so easy. All I need is a radius and a height, and boom, I can find the volume. Watch your units. Don't lose your pi. It's good, especially if it's banana cream. So hang on to that little guy. And let's see what you can do with this. Go ahead and try out example 3. Hit pause to work it out, and then hit play when you're ready to check your answers. So for example 3, we are again asked to find the volume, only now we're finding the volume of a cylinder. We were saying that this was really nice and easy to do, that we've got pi times the radius squared times the height. You can see from our lovely diagram that my radius is 3 and my height is 8. So I'm going to go ahead and put those where they go. Please don't forget your order of operations. You need to do your powers before you multiply by the height. So make sure you do your 3 squared, which gives you 9, before you multiply that by 8, which gives you 72. Don't lose the pi. Always come back and double check. This one says to leave your answer in terms of pi, so I'm going to leave it as 72 pi centimeters cubed. Just make sure you always check your directions very quickly before you move on to the next problem, because of course it could say to the nearest tenth, nearest hundredth, nearest thousandth. There's always all kind of options. I love it when it says to leave it in terms of pi because then I don't necessarily have to grab a calculator and I can be lazy. Feel like this was a bit too easy? So I'm going to mess with you just a tiny bit and take you to example 4. Go ahead and hit pause to work it out and then hit play when you're ready to check your work. So we don't care that the cylinder's oblique. We said that the problem still works, the rules still apply. It's still going to be the volume equals pi r squared times the height. My height is 16, but watch out. Remember that r stands for radius. That 8 meters isn't the radius, it's the diameter. So how are you going to find your radius? Cut it in half. How else? So it turns out my radius is 4 and my height is 16. And then I can go ahead and plug these guys in. Remember to square it first, so that gives you 16 times 16, 256 pi. But if we look at the directions, it asks us to do this to the nearest tenth. So I went ahead and grabbed a calculator and did 256 times, used the pi button on my calculator, and got about 804.2 meters cubed. Feeling pretty good about these? I like the cylinders. They're pretty easy. So if you know what your base is, you can totally find the volume. It's really not that bad. But again, I feel like all of this is just way too easy for you guys. So I got to kick it up a notch. I would like you to find the volume of this backpack. Go ahead and hit pause, take your time working it out, and then hit play when you're ready to check your answer. So this backpack's a funny little guy because if you'll notice, it looks like you have kind of a prism on the bottom and you've got half of a cylinder up on top over here. So I am literally going to slice these into 2 pieces. Please don't actually slice your backpack in real life. Your parents might get a little upset with you about that, so don't do that. Now, you remember how this whole height, let's come back here, our whole height was 17? But if we cut this in half, this is 12 inches is the diameter of my cylinder, which means the radius would be 6 inches, which means that would be 6 inches. So if I did 17 minus 6, this tells me the height of my prism is actually 11 inches. So if you're wondering where that 11 came from, it was not my imagination. The entire diameter here matched this guy here. So it was 12, which means my radius is 6. So if I subtract that from the 17, I get 11 for this little edge right here. And all I'm going to do now is find the volume of each of these pieces and then add it back together again. It's really not that bad. So I'm going to do the area of the base times the height for my prism. And it's half of a cylinder. So I'm going to do 1/2 pi r squared times the height for my cylinder. Now the cylinder piece you can see is super easy, right? Radius squared times that by your height, which is 4, no problem. If we consider this guy to also have a height of 4, then that means this would be the base. So you'd find the area of your base by doing 11 times 12. Sorry if it got a little crazy there on the screen, but 11 times 12 will give you 132 square inches. Times that by your height, that would give you 528 inches cubed. For this guy, we went ahead and plugged in our 6. We went ahead and plugged in our 4. 6 squared is 36 times 4 divided by 2 because it's half a cylinder, and I get 72 pi inches cubed. But that pi is causing a problem. They're not like terms. So I'm going to go ahead and grab a calculator and work out 72 times pi and then add it to my 528. And I get approximately 754.195 cubic inches. I get it. That problem was a little intense. And if you need to go back and go through it again, I totally understand. I hope this lesson helps. As always, go ahead and write a few sentences summarizing what today's lesson was about. And as always, if you have questions, come talk to me. You can email me. You know I'm available after school Tuesdays and Thursdays. Come on down. Let's get it all worked out and make sure that you're okay and that you know what's going on. In the meantime, I'll see you next time.